good afternoon or good evening. Whenever you're watching this video, I hope it finds you well. Hopefully you're not worrying too much over your test, but that's why you're here. We're going to do some review for Chapter 10. This is specifically for the spring of 2021, so go off this for what should be on it or not. If you're watching this for a different section, defer to what I've said recently about what will be on the test. So what we're going to do is one question from each section from Chapter 10 and hopefully explain it well enough that you can understand what to look for and just get a little practice under your belt. Each of these are coming from the book, and I'll have the page number and the problem as well. So if you want to look at what the question looks like in the book, in the context, you can. But feel free to do that either while you're watching it or after you're watching it. Remember, if there's at any point me going too fast, please know you can always stop the video, rewind, you can slow me down, whatever you need to do to help understand better. So this is our first problem. It comes from 10.1, page 702, problem 19. Everything on here is in the instructions, and then we'll do our work over here. We have these two circles with circle J and circle K. Circle J has a radius of 10 units. It's important they're giving us the radius. And circle K has a radius of 8 units. And we're told BC, this little gap right here, is 5.4. And the question tells us to find AB. Find AB. That is from here to here. This is a problem that had like a group of problems with it. So they had like find this segment, find this segment, find this segment. And this is just one of the segments I picked. And so this one, hopefully you think it's pretty easy if you look at it. You don't need all of this information actually. We don't actually need to know anything about circle K. What we're going to be using isn't going to use circle K. We are going to use A to C and then this BC segment. This BC segment is 5.4. That's right here. That is 5.4 right there. So what we're going to do is we need to find the whole length of this circle and then take away 5.4. So the whole length of the circle is twice the radius. So it would be 20 units long total. And then we're going to take away 5.4. And we get 14.6 units long. So that is from A to B. Whenever we see an overlap, we're normally going to subtract something there. We're normally going to subtract something there. So that's our 10.1 problem. That is our 10.1 problem. Once again, if you need to pause the video, if you need to slow it down, rewind it, do so. Whatever helps you understand it. Here's our 10.2 problem. It's going from 709, problem 5B. It's actually near the examples. So it comes from that area. We have this circle. We're told the diameter is 14 and this angle is 80. And we're looking for the length of this arc. We're looking for the length of arc AB. If you have a note sheet handy, you can look at that. And what we're going to be using is this equation, if you remember. We have the length equals theta over 360, and that's just an angle. That's just when we have x for a variable, we have theta normally for an angle times 2 pi r. Well, we actually have the angle already. We have the angle. So this is 80 over 360. And that is a little bit more than 1/4. 80 divided by 360. I'm just typing this in directly. This is 0.22 repeating. So it's about 22%. If you see here, this is 14. Our diameter is 14. So I didn't use my radius. I need to cut that in half. So what this is going to be is 2 times pi times 7. 7 is half of 14. We're given the whole length as 14. So we have this. So 14 pi. I'm going to use the pi button on my calculator. That's going to give me an exact answer. 4398 and some decimals. I'm going to try to keep those in, so I'm going to multiply it by that. So I'm just going to multiply by 0.22. And I get the length of this equals 9.67 centimeters. So remember, what this is saying is how much of this circle are we using right here, just from A to B. What this number is, this is the whole thing. This is the whole circle's circumference. And we're not using a quarter of the circle. We're using a little less than a quarter. That's why this is only 80. If it was 90, that would be exactly 1/4. Then that is reflected right here. We're using 22% of the circle. And then so when we put those two together, we can get our final answer. Make sure you put the units. That's very important. Don't forget those. 9.67 centimeters long. All right, on to the next one. So 10.3. This problem comes from page 718. This is problem number 5. We are looking for PQ. We know JK, that's this line, and we know the arc JK is 134 degrees. And we know the radius is 6. We actually don't need some of this information. I'll show you what we're going to use in a little bit. If you're paying attention, what we're looking for is this, that little segment right there. It's going to be less than 6. So we know our answer is less than 6 because from here to here, from P to L is 6. So our answer is less than 6. This is a smaller number. What we want to do, though, is use the pieces we have to let us know how to solve this. So we know J to K is 10. So if we know J to K is 10 and we know we're hitting this at a right angle, that means we're going to split these in half. So each of these is 5. Okay. Now, I'm actually going to draw a new line. I'm going to draw a new line that is right here from P to K. So I'm going to add that line. This line is also 6 long because anything coming from the center and going to the outside is 6 long. If this is from here to here, that'd be 6. From here to here, that'd be 6. So I know this is true. So I know this is 5, this is 6, and I'm looking for this. Well, what I've just done is I made a right triangle. I made a right triangle that looks like this, where this is 6, this is 5, and this is PQ. It's this one right here. Let me color it in. See if that helps visualize it any better. So that is the triangle I have made. And so now all I'm going to do is solve this with the Pythagorean theorem. Solve with the Pythagorean theorem. Make sure you put 6 by itself. This is our C, and these are our A and B. So we want PQ squared plus 5 squared equals 6 squared. What is that? 11. So PQ squared equals 11. PQ equals the square root of 11. That is a number that's going to be between 3 and 4, because 9 and 16, it falls in between those. If I want particulars, I'm going to put in my calculator. It probably isn't going to come out to a whole number, but that's okay, or a clean number. 3.32. 3.32 for P to Q. If we wanted to find QL, that's not in this problem, but if we wanted to find that, we'd have to do all this first, and then we'd subtract this from 6. So if we wanted to find that, we could. But we were finding PQ in this instance, and I get 3.32. That is your 10-3 problem. Most of these that we're doing on here have some sort of comparable one in the notes on Schoology. So go on Schoology, find your notes, and match those. Okay. 10-4. This is coming from 727. Problem 8. We're looking for angle R. That's this one right here. We have a circle. We have a line cutting through the middle, and we know that because it hits this point. And we have this little shape. So what we know about this is this has a right angle. When we have a circle where it passes through the middle and then something like this, we have more than, we have 180 degrees right here in this arch. And if you remember, inscribed angles are going to shrink that down to a 90. So that means the one opposite the full arc is going to be 90. So if you look here, this is not totally full. This is a tiny one. Opposite this arc is my 90. And so if I shrink that down, that means angle Q is going to be a 90-degree angle. And now we have a triangle in here. All we have to do now is solve this like we did triangles. We know all three are going to add to 180. Well, I've already spent 90. So these two are going to add to 90. All three of these add to 180. And I've already spent 90, so I know these two are going to be 90 degrees when I add them together. They're not going to be the same thing more often than not. They're always going to equal 90 when you put them together. That's going to be 10x. 10x equals 90. Those ones are going to cancel out. 10, x equals 9. Now that is not our answer. Remember, the question was looking for the measure of angle R. So all I have to do, take 9, plug it back in, angle R. That's going to be 63, if you ever do the hand thing. 63 minus 1, angle R, is 62 degrees. All right, that is 10-4. That is where your quiz stopped, those 4 sections. We're jumping into 10-5. It is very important you keep a nice, neat note sheet for this test because there's so many different sections and different things going on in each one. So make sure you're able to decipher between them. What we're doing is we're finding what x is equal to, also known as the radius, what the radius is of this circle. We're going to assume that 30 is a tangent. If it looks like a tangent, just assume it's a tangent. For some of these, that'll be in the instructions as well. And this is 18. But what is 18? 18 is actually this piece right here, not this as well. There's a sneaky missing piece to this question. This is also x. This is also x. So first thing to note, that is also x. We're not going to normally get values for the whole length of it. So this is just the outside. We're going to do the Pythagorean theorem. So we're going to do the Pythagorean theorem. So we need to figure out which one of these is my hypotenuse. Hopefully it's visually apparent to you. But if not, know that your tangent is going to be one of the legs and the other one's, the radius is going to be the leg. So that means this is my hypotenuse. This is my C. I'll make this B and this one A. It doesn't really matter which one's which, but we'll make those. So here is the problem we're solving. We're solving x squared plus 30 squared equals the whole hypotenuse. And this hypotenuse is x plus 18 squared. That's C squared. A squared plus B squared is C squared. 30 squared is 900. So we can clean up this side pretty quickly. But this over here, let's do a sidebar over here. So I'll solve this half over here. If you remember, what this is 2x plus 18s. Some of you did this last year, this method. We did another one in class once. I'll do this method. I thought this was pretty neat when I saw it for the first time. X and 18. So all we're going to do is multiply each combination. So we need to multiply the x's together. 18x, 18x, and 18, 18, 324. Okay, so that means this is equal to x squared plus 18x plus 18x plus 324, which translates to x squared plus 36x plus 324. So that's just what this half of the equation equals. We have to do that whole work just to get that second half of the equation. But the good thing is that's towards the end of the question already. 324. And then I'm just going to start cleaning it up. Minus x squared, minus x squared. So 900 equals 36x plus 324 minus 324 minus 324. 576 equals 36x. 576 equals 36x. Divide by 36. Divide by 36. And we get x equals 16. X equals 16. So we have a right triangle. The hard part, I think, is really this area if you haven't done that in a while. But I think once you have a couple examples in your notes, it gets a little easier. From there, the problem kind of solves itself, just straightforward algebra. We end with x equals 16. If we want to test this, we can plug 16 back into these and see if it's a right triangle that works nice and easily. So that's 10.5, a little harder problem, but make sure you know these in case they pop up. They'll definitely be a very big part of Algebra 2 next year, but make sure you can do them now. All right, we are almost there. Thank you all for doing so well already. If you need, or if you feel good about some sections and only want help on others, don't be afraid to skip around. Yeah, have I used all the colors? I think so. No. What color haven't I used yet? We used red, we used blue, we used pink, we used green, we used orange, purple. Purple. All right, we're finding the measure of arc xy. We know it's an arc because it's written right there. Arc xy. And what we're going to do is go the close way around. That is this piece right here. We have this outside angle being 41 degrees, this kind of inside arc being 103, and we don't know this. So we want this. We don't know this at all. And so we're going to solve this. If you remember, we had kind of the pseudo math formula, and not in the book formula, not in a official math textbook, but kind of our own version. And it was this. It was 2 times the outside angle equals the big arc minus the small arc. That was like our equation that we can use to solve just about all of these. No matter if we have 2 secants, a secant and a tangent, or 2 tangents. So our outside one is 41. our big one is the one we do not have. Our big one is the one we do not have. I'll just call it xy, because that's the name of the arc, minus 103. Okay, that's 82 equals our arc that we're solving for, minus 103. If you know your math pretty well, if you're doing these algebra steps pretty easily, and I think most people have been because we've been doing it all year, these problems, once you have the formula, are not going to be too hard. And there we are. It is 185 degrees. This isn't really drawn to scale perfectly. It should probably be around here if it was 185, but you get the picture. We have this going all the way around. This is like our equation that we're going to use in most of 10.6. We have another one we used when we had two crisscrossed and we wanted to find arcs. But when we had this like cone shaped, we used this one again and again. Very important to remember the different kinds of questions we have. All right. And 10.7. If you are an on level, this is where your problems would stop. If you're in honors, you have one more section after this. I'll make sure to flag this so you know when to stop. This one's very similar to what we just did. Very similar, except in 10.7 we talked about the length of it, the actual pieces of the lines, not the arcs themselves. So now we're talking about the individual pieces of the line. And just like we had one pseudo-math equation of this, 2 times the outside equals big minus small, we have another pseudo-math one, another Mr. Goodrow original, and that's this. The whole line times the outside piece of the line equals the whole other line times the other outside piece. And this works for both 2 secants or 1 secant, 1 tangent. So for example, in this line, the whole line is x plus 4. That is the whole line. Remember, this is x right here. This is 4 right here. So if I want this, that's x plus 4. The outside is just 4. And on the second one, the whole line is 6. And the outside, well, everything is outside. So that is 6 as well, or 6 squared. Well, this side, I don't have 2 binomials like I did earlier. I don't have 2 binomials. When they're sitting side by side like this is when I do this. If it's just like x plus 4 and 4, we're just going to distribute that in. So that's going to be 4x plus 16 equals 36. And then we just solve. X equals 5. So the important thing about this is these don't have to be the same size. They probably won't be, but this idea will always hold true. This idea will hold true that the whole line times the outside will equal the whole line times the outside. Sometimes they'll crisscross both in, and this will still work. That's why I like this so much. It's one formula for the whole section 10.7. We also did another one where we had chords crisscrossing. It was very similar, a little different though. So make sure you look at that. Make sure you have that on your note sheet so you can do any 10.7 problem I throw at you. All right, our final question is an honors question. So honors question, watch out, watch out. If you are an on level, turn back now. We have 10.8. Write an equation for a circle with a center at this, and it passes through that point. We actually haven't done one like this, but it's not that different from what we have done. So let me show you. Equation for a circle. Let's write that out. The equation for a circle, remember, is x minus h squared plus y minus k squared equals r squared. And we have these are three of our inputs. We input h, we input k, and we input r. H and k are the center point. And we know those actually. We actually know those now. Start using colors. So h and k, in this case, are going to be -3 and 6. So we have 2/3 of the problem solved. 2/3 of the problem solved because all we're going to do is plug in right here. What we need to find is our radius. And hopefully you can look at this and just understand that. But let me draw a quick little diagram, and I think you'll get it. So -3, 2, 3, 1, 2, 3, 4, 5, 6. So that is where the center of the circle is. And it passes through 0, 6. That means the circle goes around like this and hits that point. This is our center. This is outside of the circle. So this is our radius. That is our radius. And that is 1, 2, 3 away. So this helps me know what my radius is. That helps me find r. So our radius is 3. I don't know, something like that. So let's plug in now. X minus -3 becomes +3. Remember, the default is minus. So if you see a positive, that means it's double negative. Y minus 6 equals 3 squared. That's 9. So a circle that passes through that point, that hits that point in some way, and then it has its center there, would be that circle right there. So that is the kind of problem you'll see from 10-8. Not a very complex one. Just want to make you aware of just kind of what that one would look like. This is on page 70, 760, problem 17.